Hello, everyone, and welcome. It's Wednesday, April 20th. We are getting together for our 101st consecutive weekly Knowledge Bolide Hangout, sponsored by Topher Spin Meteorites. Tonight's show is actually, I have to look at my notes. It's called Device Advice from Cosmic Collectors. So the goal of tonight's Hangout is basically to talk about the tools that we use on a day-to-day basis to enjoy our collection, to get the most out of our collection, and to make our collection last as long as possible. So we have also a great demonstration. We talk about polarized light and cross-polarized light quite a bit. So one of the YouTube viewer questions fit in with today's subject matter of tools and equipment. So we're going to have Honorary Professor Pat give us the wiki demonstration of polarized light. First, though, I want to get into a video that Damjan Silkovic sent us from Croatia. We've had this in a can for a few weeks, waiting for today's show on equipment. Damjan is going to talk about macro photography equipment. He's going to talk about different price levels from low end to higher end, and what you will spend and what you can expect from each level. So Damjan, take us on this journey of macro photography, please.
A big hello from Croatia. We all love collecting meteorites, but I'm sure we all love showing them off even more. This often requires macro photography and videography. For beginners, this can be quite intimidating, considering how much different and often crazy expensive equipment there is out there. I would like to show that it doesn't really have to be complicated or expensive to take wonderful macro photos of your cool new meteorites. So, introducing macro photography for beginners. This little Altai slice will be our model for today. To better compare between different magnifications, a millimeter scale will also be shown. A few of us have a dedicated camera, but we all have mobile phones, often with excellent cameras. The problem is that the main phone cameras that give you the best quality are also terrible at focusing at close range. Even though there are macro add-on lenses, most are pure garbage. Luckily, some are also excellent, like this Apixel 200mm macro lens. It's built like a tank and offers excellent optical quality, with respectable edge sharpness and almost no chromatic aberration.
Damjan did want me to tell you guys he made a mistake. That is a 100mm, and I'm going to have all the links to these items he's talking about. Excellent.
This is the closest I can get with my main camera without the lens. And this is with the add-on lens. The magnification is not crazy high, but it's quite useful. A medium magnification together with a large working distance makes it excellent videography lens. For even higher magnifications, this Apixel 200x macro lens with built-in LED light is possibly the best one you can get. The edge sharpness is again surprisingly good for such a high magnification add-on lens. The light works perfectly, and it's even got built-in polarizing filter for better reflection handling, though it's not full cross-polarized setup. You could even use it to photograph your thin sections on another LCD screen as polarized backlight. It can even handle videography of flat pieces. The magnification is high enough to nicely show chondrules. Would you have guessed that this is taken with a $20 add-on macro lens that you can carry in your pocket? Marvelous, isn't it?
Yeah, it is.
If you need an even better quality, you basically have to switch to a dedicated camera. It doesn't have to be the most expensive model, but it does have to have exchangeable lenses. The kit lens is usually not terribly good at macro photography, but can luckily be improved. A cheapest way to get better macro photographs is to mount your kit lens in reverse. I know it sounds and looks funny, but it actually works. You do this by purchasing a cheap and simple reversing ring adapter. The resulting image quality is not exactly stellar, but it does give you a very large magnification range. This is the lowest my particular lens can go, and this is the highest. Please ignore slight blurriness because my focus point was not perfect, and you also do have to basically do focus stacking at these magnifications. For better results, you can use a higher quality prime lens, such as this 50mm Zeiss. This way you can get much sharper images. Lenses can also be stacked. Here I've added another 50mm Zeiss lens. This combination gives you a much higher magnification while still being quite sharp. This has been my main setup for the first 10 years of my macro photography. Another way to focus closer is to add cheap extension tubes. You do lose a tiny bit of sharpness with cheap lenses, but you also get much higher magnifications possible. Here are a few more photos with this setup. For the ultimate level of macro photography, you basically throw away all of your standard lenses and switch to directly using microscope objectives. Even though they can be crazy expensive, there are some stellar performers in the low budget range, such as this excellent Amscope 4x planar objective that can be bought for as low as $20. Most of my recent macro photographs have been taken with such a setup. Not all of my macro experiments have been successful. I've tried to use a Raspberry Pi high-quality camera with an industrial macro lens. Even though the sensor quality is much better than a typical webcam, it's still worse than even a phone camera, so I gave up on the idea. The importance of high-quality lighting in macro photography can't be overstated. If you want the best, you want a cross-polarized lighting setup. That means you have to mount one polarizer over your light source and another one over your camera lens. IKEA lights are quite useful for videography or to help with framing, but you need something much more powerful for high magnification macro photography. Even a cheap off-camera manual flash will do the job. Even though there are a lot of things I haven't mentioned, such as macro rails to help with focus stacking, you should now have a much better idea how to start with macro photography on basically any budget. By combining these tools and techniques, I am sure that you'll in no time be able to produce some stunning macro photographs. Thank you for watching.
That's pretty good stuff.
A big
So I'd add one thing to what he said is that when you're doing these techniques using the tools that he's mentioned, you're going to be exposing manually. So you need to understand a little bit about exposure because you're not going to have control over your f-stop. But on most digital cameras, the regular digital camera, you'll still have your shutter speed and ISO. And if you're holding it, if you're doing it, putting it on a tripod or something to keep it still, you can use a longer exposure. And again, and he mentioned light, but it's like you need a lot of light, a lot more than you think to get a good exposure. If you have a camera that has that, that has a macro lens, then you would go with macro.
Yeah.
But to get the best results, you're going to be in manual mode, because a lot of these things you don't have the electrical connection. You know, with the reversing ring, your lens is backwards. With the extension tubes, they're most likely still not connected. There are extension tubes that do have the electrical contacts, but the setups that he's got with the with the microscope lenses and things like that, it's going to be all manual, just old fashioned. You'll lose the aperture control primarily.
A device that I found very useful is a flatbed scanner if you don't have access to high-powered photography. I've had really good success with a 13-year-old scanner that I set to 1600 DPI. I get pretty good results out of that.
Wow, that's pretty wild. I didn't even think about that.
Oh no, it works great. You can this one I have is a Canon. I can zoom in to the piece itself, set it to extremely high DPI as far as it'll go, and scan it. And then any errors, like dust particles, I can take out through photo imaging software. But I've been using flatbeds for years, and you can get some really nice shots.
I want to share my super expensive photography tools. You're looking at $40.
I bought me one of those photography cubes. They work great.
Yeah, this photography cube is amazing. You can change the temperature on it. It has a diffuser built in.
Yeah.
I also recommend buying a nice cell phone scanner. You put your cell phone on there, you got flat surfaces, and it really does take exquisite photographs for what I do.
Yeah, the white dot comes with different colored backgrounds you can insert.
Yeah.
And those really make a difference. I started off with red, and I've been using the blue one lately. And it really does nice wonders for the back, the contrast and whatnot.
And Allison is going to share a little bit of her tools and equipment, her devices, her device advice. Now, Allison is going to give us a little bit of information from kind of like a newer perspective of maybe shifting from a rock hound or a hunter into the collecting, and she's going to talk about some of the tools that she uses to do that. So Allison, are you with us?
Yeah, so I am a meteorite hunter. I have been for many years, but I still have not found anything yet. So I'm by no means an expert, but maybe I have some tips that'll be helpful for others who are getting started in meteorite hunting. So my first bit of advice is buy yourself some real meteorites to look at, and actual meteorites. That's going to be so helpful when you can compare actual meteorites to the rocks that you find in the field. Get a feel for them in your hand, get a feel for them on your magnet. The second bit of advice that I have that is probably even more important than having meteorites to look at is to get a local geology book. If you can learn about the rocks and minerals that you can expect to find in your neighborhood, then you don't have to learn all of the billions of rocks that are on planet Earth.
I love that.
So if you can get into your local geology book and just pull out some of these words for some of the rocks that you may be finding, feldspar, quartz, magnetite, galena, whatever it is that you're, maybe finding in your area, then you can compare that to the rocks that you're finding in the field. So I know for sure that that's a piece of magnetite. And then I'm not asking everybody, is this a meteorite? Is this a meteor wrong? I'm answering my own question. Here's a bit of iron ore that I've found. Again, knowing how the geology has shaped your neighborhood and what to find is so helpful. Also, when I'm out in the field hunting for meteorites, I take just a simple piece of sandpaper and a meteorite ID kit and an aggressive file. I can get a window into most any rock with those things, and if they look like they may be a potential meteorite, I can take a nickel test to them and find out if they are or are not. Again, you need to know your local geology because you may live in a place where nickel is found. And I have a jeweler's loop that I use both in home and in the field, and just a cheap microscope that I can hook up to my tablet. My favorite tool of all, though, is my magnet stick. I take it everywhere with me. It helps me find magnetic rocks.
Without bending over and breaking your back.
That is fantastic. That's a nice little starter kit there for the experienced rock hunter / meteorite hunter. That is really good. Do you carry? I see an earth magnet on that iron ore. Do you carry an earth magnet with you?
Right on my meteorite.
Oh,
stick,
there
I
it
do,
is.
yeah.
Okay, awesome. Well, that is really much appreciated. Was there anything else you wanted to share?
Yeah, no, that's all just really affordable things that you probably already have lying around the house, if not really easy to get. So again, learn your local geology, and that's going to help you to answer meteor right, meteor wrong. And you know, buy some actual meteorites, get those in hand. That you know, there's a common saying that there are a lot of meteorite hunters and very few meteorite finders. So be patient and stick with it and enjoy yourself when you're out there.
Wow, that is some great advice. I didn't write that and it wasn't scripted out, but thank you. That's fantastic. All right, I just wanted to share a little quick something with you guys. We have over 4,900 subscribers on the YouTube channel, and only 36% of the people who watch our channel are subscribed. If everyone would click the subscribe button today, we'll have close to 13,000 subscribers. What I'm asking for you to click subscribe for is information that you get nowhere else, like Professor Pat's one-on-one wiki demonstration that we've been waiting so patiently for.
Hi all. Today we're going to talk about reflected cross-polarized light and a trick that we can use to look at the true surface of the meteorite underneath the desert varnish. Desert varnish is a layer that grows on rocks, all rocks, out in the hot desert. That material is really very similar to glass. And we're going to represent that in our mock-up here as a piece of real glass. We're going to take light and we're going to filter the light with a linear polarizer. Now, a linear polarizer is just a filter that looks like a series of slots that filters out all light except that is vertically polarized in this case. Our polarizer is vertical. So here's room light coming down and hitting the polarized filter. All of this other stuff that is of other polarizations we don't care about, we lose that. And the only part that goes through the filter is the vertically polarized light. Now, that vertically polarized light is going to come over here and hit our meteorite. But we have a piece of desert varnish in front of the meteorite, and this vertically polarized light is just going to reflect off the first surface of this piece of glass representing the desert varnish. So most of the light will reflect back, and if we illuminate with the same filter that we look through, that light comes straight back through and up to the camera. So we haven't accomplished anything with one filter. The trick is we have to illuminate with a filter in one direction and look through a filter at 90 degrees to that. So what that'll look like is we've got our room light here that's coming down, hitting the polarizer. We're filtering out all of these other polarizations and just having the vertically polarized light go through the filter. It comes down here. Most of it reflects off the front side of the desert varnish, represented by a piece of glass here, but some goes through the desert varnish and hits the true surface of the meteorite. Now, that light, just like any light, when it hits a solid object, will experience polarization scattering. So it'll bounce back in all sorts of different polarizations. We are going to select the part that reflects back at 90 degrees to the polarizer that we used for the polarized light to illuminate the sample. That light is going to come back, go through our second polarizer. This is the polarizer in the observation path that we're looking through, and go back up to the camera. The way we accomplish that on the Meteorite cam is we have a light source, in this case LEDs, that shine through a linear polarizer. Notice that it has a hole in the center. So this polarizer is only in the illumination path, and we can rotate it so that we can create polarized light in any direction that we want it. There is, just like with our mock-up example, we need a second polarizing filter. That second filter is here, and it actually lives inside the ring of lights. But this filter is not used for illumination, it's only used for observation. So the light that's reflected off of the meteorite, most of it reflects and is lost. The part that goes through the desert varnish hits the true surface of the meteorite, reflects back, and we're going to select out, by looking through this second filter, we're going to select out the part that is at 90 degrees to the filter that we use to illuminate with. And that will allow us to see through the desert varnish and see the true surface of the meteorite. So for the next part, we're going to hop onto the Meteorite cam, and I'll show you what that looks like through the Meteorite cam. So now we're on the Meteorite cam, and we're going to see the benefits of this technique. So right now, the two polarizers are parallel to each other. So what's happening is we're illuminating the sample with polarized light. The majority of that light is reflecting off the front side of the desert varnish and bouncing right back up into the camera. Because the filters are parallel, we're seeing that part of the light that's reflected off of the front side of the desert varnish. But if we rotate our filters by 90 degrees so that we're illuminating the sample with the same polarized light, we're ignoring the part that reflects off of the front surface of the desert varnish. We're looking at the light that's going through the desert varnish, hitting the true surface of the meteorite, experiencing that polarization scattering, and some of it reflects back off the true surface of the meteorite at 90 degrees to the light that we're illuminating it with. That, because now we have our filters at 90 degrees to each other, we're able to see that light traveling back up to the Meteorite cam, and instead of seeing the front surface of the desert varnish, we're seeing the true surface of the meteorite. The other thing that this technique is valuable for is if part of this was real fusion crust and not desert varnish, it would just look black even in this special technique. So we can tell what's fusion crust and we can tell what's desert varnish. This piece has essentially no fusion crust on it and just desert varnish, so we're able to see the chondrules underneath the desert varnish. Thank you.
That was phenomenal. That was absolutely phenomenal. It's hard for me to believe that this is the exact same rock there and there, just a change of lighting.
Yeah, it's pretty incredible.
So that is why we are constantly droning on and on about polarized light and cross-polarized light, and we have it on our microscopes. I'd like to get I think now I'm motivated to get some type of cross-polarized setup on my cell phone. So that's the next step. Does
I
anyone,
think he definitely earned that honorary professor title
Yeah.
today.
yeah,
That was
honorary
excellent.
professor for sure.
I'm really hoping, guys, that wasn't too technical, but I wanted it to be scientifically correct.
No, I thought it was really, the thing that was really advantageous for me was seeing the room light in all its confusion. and how we strip down the layer. And then, yeah, it doesn't really do anything to have one filter. You have to have two to cross polarize, to take out even more information. So yeah, I thought that was really good. Does anyone have any questions about cross polarized light? Art?
I just wanted to know if there's going to be a test later.
Test it and applying it. We want to see your cross polarized setup. That's the test.
It
Yeah, I
was
think
it was very technical, but you explained it very clearly.
Yeah, I thought that was a really good explanation, Pat. The only question that I have, is because I haven't screwed around with it, is if you go to a camera store today to buy a polarizer for your camera, most of them are circular polarizers, not linear polarizers.
Right. And I
So-
should mention that this technique doesn't work with circular polarizers. You need a linear polarizer.
So
Okay.
you buy linear sheets of,
Yeah, you can buy sheets of polarizing material, and the sheets of material actually have better performance than a lot of the old photography linear polarizers.
This is a demonstration to show how the light, the filters, even though they're tiny little filters, they do filter out the light in certain directions.
Right. So here's two pieces of this polarizing material. And if we put them in front of each other, we can see at some, now these have plastic film over them, so they're not optically that perfect. They ship with a film on them, you need to take off. But when we get to 90 degrees, it'll block all of the light. So the real trick with this scheme is to have one of these in front of your light that you're illuminating with, but look through another, and you want to look through them at 90 degrees. You can't stack the two of them because nothing makes it through when they're at 90 degrees to each other.
That's cool. I can even do that with my polarized sunglasses. If you have
Yes.
if you have a pair of polarized sunglasses, you'll hold them up, look at your computer screen and rotate them. They'll go to privacy mode.
Yeah, I've got a car with a head-up display, and it's like the polarized sunglasses that I get in the car. I'm like, oh crap, because it just wiped out the head-up display. So I had to get non-polarized sunglasses.
well, you can take them linear sheets and you can cut a circle to the inside diameter of the eye tube of your microscope, and you can just gently feed it down to where it will stop, and it will still work with your microscope and your camera set up to your microscope, you know, so.
Yeah, you just need one fixed and one that you can rotate and tweak.
Right.
Well, we have, as a crew, have been discussing what a good project and a crew project and a crew production would be like to create a meteorite glossary, an interactive meteorite glossary. And Jim Shelton raised his hand like, wait, I've already started. So check out Jim Shelton real quick.
I started this when I first got started in meteorites. I still keep it in the drawer and look at it once in a while. I copied a lot of these illustrations off of Wikipedia and put them in a Word document. And I've got 6 or 7 pages here of glossary information, and they're random. It's when I didn't know a term, I looked it up and added it to the list. So it's in no particular order, but it's been very helpful for me.
That is awesome. And you're going to make that available to the crew?
Yes.
Awesome. Yeah.
Great.
Thank you very much. So we're going to take that and we're going to beef it up. We're going to take all the terms that we throw around every single week, like slick and sides, oriented, flow lines, brecciated, CAIs, all these things that we take for granted that everyone understands. And we're just going to put together a little production glossary and interactive presentation. So look forward to that in the upcoming productions. Right now, we're going to kick it over to Bruce. Bruce, what do you have for us, man?
So I have a little eye loop, and it basically, I got this off of eBay, and I don't know if you can read it there. It's a currency detector microscope 60X. And so over here, you can see that there are 3 LEDs, and hopefully I'm not going to blow. Let me turn this down. So there are 2 white ones, and then there's a UV one. If I remember, I think I tried the UV. I don't think it's the right frequency for meteorites. But basically what you do is you can take it, you angle the light so it's going to point down, like your sample is going to be here where my finger is.
Mhm.
And then you look through where the black is, that's the eyepiece. So I find it easier to lift it up and then, you know, put this right on the piece and then look down and focus in on whatever it is, because it's not going to be flat. So you're going to probably need to move it up and down a little bit. But I got this on eBay for less than $10, I think. And I think I remember it, with the batteries, it's maybe a little more. But it's a nice little thing just to look at. You know, you can really zoom in on the chondrules. You don't have to go and set up a whole microscope or, you know, macro camera. It's like, just take it, put it to your eye and take a look.
That's fantastic. Thank you, man. Yeah, because sometimes, like, I have a microscope, a lot of us have a microscope, but sometimes it's nice when you don't have the cash for it, or you want to be mobile, to have a tool like that. And when we went to Tucson this last year, Pat Brown had a mobile tool that really gave us an advantage. So it fits right in with our equipment and also his presentation on polarized light. So, Professor, in quotes, take it.
Yeah. So here's the device. I'm giving away my secrets.
Sorry.
This thing is made of ABS plumbing, actually sewer pipe pieces, and one of these light rings. So it has LEDs on this end and the two filters, and the ABS pieces are so you can use it in direct sunlight. Here it is looking, and I didn't do this a minute ago. Here I'm rotating the filters, and when I get them at 90 degrees to each other,
Wow, that's
and
cool.
no, sorry, it's not focusing very well, but
It looks good.
Yeah,
then you can see the surface of the meteorite rather than the desert varnish.
that is fantastic. And when we have that, like, I know that your cell phone is trying to focus on the dust on the lens right now, on the last filter. But when you have this in hand, it is truly a powerful tool that look right through that desert varnish and see what you're actually looking at.
Yep, and each year I've been to Tucson, I always invent a new one. But this one, I think I finally hit a stride with. It really does give an unfair advantage, and I was extremely popular digging through boxes of meteorites. This technique also works on slices. It's not just on whole rocks, but on slices. When you're looking under your microscope and you see just a bunch of reflections. It's not that interesting, other than you can see the metal, and in this one you can see some armoring around one of the chondrules. But rotate the filters to 90 degrees, and now all of a sudden you're able to see. I'm sorry, it's not focusing well. All of a sudden you're able to see a whole lot more detail in the slice. So I basically have one of these reflect across polarized light things on all of my microscopes, the one out in the lab, the one out in the workshop, the ones here in the lab. And it's almost magic, but it's real science. Thank you, Topper.
Awesome. Thanks, man. And you have a 1 hour edit veto. If you don't contact me in an hour to edit it out, that's going in. I know.
No worries.
But it is our secret power that we had in Tucson, and it's science. So that's awesome.
Is that plug-in or battery?
I've got it plugged in now to a power supply back here, but I rigged up a 24-volt battery pack, and it can run on batteries. I have some lithium ion little power packs that put out 12 volts, and takes 2 of them to get 24 volts to run this thing.
Right.
But it'll run for 10 or 12 hours easily, long enough to be able to use it portable.
Nice.
Thanks, man.
Thank you.
Every month, we like to stop and take a look at what meteorites have been published on the Meteorological Bulletin. And we do that with my beautiful wife, Sue. So Sue, we're kicking over to you for the monthly update.
Thanks, Topher. Hi, everybody. I hope you're all doing well. Welcome to the third installment of the monthly MetBull update. For our newer collectors, the MetBull is an online database that is a repository for all approved meteorite classifications. Every stone that's collected in Antarctica is considered its own classification. We don't do that in any other country in the world, but in Antarctica we do. For the purposes of this video, any number that I give you, any statistic, it's going to be based on non-Antarctic meteorite numbers. March 2022 was a fantastic month for meteorite classifications. I'm going to focus on three main areas. The first one being the number of classifications that we had last month. The second being the wide variety of classification types that we're seeing. And lastly, the rarity of those classifications. Out of the 189 meteorites, we had 104 NWAs and 4 Western Saharas. It's the country of Peru. I don't normally see them on the list, but last month they had 5 meteorites approved. And the cool thing about that is, those 5 meteorites got them to a total of 12 approved meteorite classifications. So they nearly doubled their number of approved classifications in the course of just 1 month. That is, China had their 3rd palisite classification approved, and that is for the meteorite called Wulong. It's a 70-gram single stone palisite find. It was actually found in 1990 in a farming community. The finder did not recognize that it was a meteorite all of the time that he has had it. MetBull does record the year that science recognized it, and that was actually in 2022. Was the iron that fell in Brazil, Nova Olinda. It was found by 2 brothers who are also gold prospectors. They found it in a rural farming community in a dry lake bed, and from what I understand, it was highly weathered. It had really thick deposits of camosite and also abundant Newman rings. They got it classified as an iron IIAB, but it was noted that it differs from any other Brazilian iron that has been found. Sazlader. But that actually was classified for the country of Turkey, and I don't see them on the list very often. This was actually only their 26th meteorite classification, and interestingly enough, it was their 7th iron. It was a 13-kilogram single stone find, and believe it or not, it was found over 20 years ago. It has been etched and polished, and it is absolutely covered in regoliths on the outside layer. There are at least 30 different classification types here. That's actually a lot. I don't know what the average is. I haven't had a chance to run those numbers yet, but I do know there are plenty of months that I look the numbers up and I don't see any palisites or any irons. This is a pretty impressive number of classifications and very impressive number of rare classifications. The meteorite classification for NWA 14635 and 13673. Now, the 14635 was classified by Daniel Shake, who I am proud to say is the Knowledge Bolide's preferred classifier. Now, these two are basically 2 of 2 of a new classification called a chondrite braconite-like, and it is an ungrouped primitive chondrite with properties resembling a braconite. The next one of note falls under the carbonaceous family of meteorites. It's the C3 ungrouped. There are only 24 of those classification types, so that's pretty rare. The next rare classification after the carbonaceous was actually an angrite. And before this month, there were only 33. So we had the 34th angrite classified last month. And after that one is the one that we've talked about now this time and on our last hangout was Tiglet, and that was an aubrite, and that was the 36th aubrite classified. There were 2 palisites that were approved, and believe it or not, there are only 114 palisites. There were 2 meteorites that were classified. They're both in separate classifications, but these classifications are typically bundled together. The lodgernites are typically bundled with the acapulcoites. Gadamus 004 is a lunar north site classification. We only had one of those in March. The most common of lunar classifications is the lunar feldspathic breccia, and we had 9 of those last month. Before February, it was believed that Gadamus 004 was going to be the largest a north site classification on the planet. It was going to triple the amount of a north site lunar that we have. Then all of a sudden, there was another meteorite that was classified that was actually triple the amount of Gadamus 004. It's up near 39 kilograms, with Gadamus only being 12 kilograms, but still a pretty significant find. And it is the largest lunar classification for the country of Libya. But of these more rare lunar classifications, one of those is the lunar melt breccias. There were only 7 of those before March, and in March we had 2 more of those approved. So the last lunar classification was the lunar fragmental breccias. We had 6 of those approved in the month of March, and that makes a total of 17. So that one grew exponentially in size, that classification type, and they are absolutely stunning. Okay, guys, it's time for me to wrap up the March MetBull update. So when you go to the MetBull and you go to the search, there are different parameters that you can enter. And one of them is like the location, but it's in the middle at the top. Now, go check out these 3. There's one for Mars, there's another for the moon, and there's another for the Pacific Ocean. Enjoy, and hopefully you will join me again when I am discussing the meteorites for the April monthly update. Bye, guys.
Thank you, Sue. That was awesome.
Thank you. That was good. That was nice.
Yeah.
Lots of information in there, lots of new lunars, and some homework to do. So for those that haven't tried the MetBull to see some of the stuff that's out there, there's some good stories hidden in some of the classifications. And as Sue hinted, there's some unique locations where some of those meteorites have been found.
You don't hear the phrase only 12 kilograms of lunar very often.
Yeah, it was wiped out by I think over 36 or 39 kilos of a new one. So wow.
Oh.
I got a little bit upset with Pat earlier because he now has given me the link to the MetBase database, which I guess is even bigger than the MetBull, and I was like, oh no, you didn't.
Yeah.
I'm gonna get lost on here.
That's the actual database that you can subscribe to with all the information behind the scenes, and you can extrapolate it even better. So yeah, it's a cool tool. When you're collecting meteorites, though, there's going to be a lot of things you need for curating your collection, for making sure that the inhospitable environment of Earth that's constantly attacking your meteorites is held at bay. And some of those things we've talked about on other shows are like desiccant and air chambers or anti-corrosion emitters. But unfortunately, sometimes a piece gets far beyond that, and you got to get Mike Kelly involved. And Mike Kelly is doing a little bit of projects for me on some restoration of meteorites. So I figured we'd allow Mike to walk around with his camera, see what he can capture regarding some of the equipment necessary for meteorite preservation and curation. And this especially applies to iron meteorites. All right, so I forgot, Mike actually sent in a video because he was short on time, but we're going to just go through this. And Mike, just tell us what we're looking at and why.
Sure, yeah. So you need an electrolytic solution. So the baking soda is what you're putting into distilled water to allow the current to pass through the solution and actually conduct the work. These are 2 different types of electrodes. I started out using steel. And that's the rusty piece on top. You can see it's been used. The bottom is graphite. I found graphite works a lot better. You're not cleaning off rust all the time. So that's a little more problem-free for running a tank. That was a wire brush. So you want to make sure you have good contact with your piece. So even though it's rusty, you want to clean off a little bit of the piece where you're going to wrap it. And that's going to allow the charge to get into the actual Meteorite. So you're getting good removal going on. Obviously, you need distilled water for the tank.
You never want to, because you're trying to remove chloride and all the chlorine and all the chloride. So you want to use distilled water.
Yeah, you don't want to add anything to the mix. So that's the wrapping wire. So I'm just using steel wire to wrap around the piece, and that's what's going to transfer the energy into the meteorite. That's just an example of wrapping it. Again, you want to wire brush it a little bit to make sure you're getting good contact area.
I was hoping that was my Munianalusta.
No, your Munianalusta is already in the tank.
Nice.
So there is a large chunk of Sriracha, and as you can see, I just use the wire and I hook it over a little stick in order to keep them all within the solution. And what you could see there is you could see the one alligator clip, and I clip all the pieces together that are in the bath. And you can see in the background, there's a piece of the graphite cathode in there that's hooked up. And that's a DC power supply. They're like $60 online. They'll put about anywhere up to 30 volts. And I think the max is 10 amps. I only run about 1 amp to 2 amps. 2 amps is really hot. 1 amp is about nice and where you want to be. And again, you can adjust that by how much baking soda you put into the mix in order to get the conductivity high. You can see the juice in the tank is all black. So as the rust comes off of the meteorites, the graphite kind of flakes apart and you get that black soupy goo. So then one of the hardest parts of running it is you got to get all that off of the piece when you're done running it. So getting it off and using a nice nylon brush to get all the graphite and coating off after it's been cleaned is key.
Now, how long roughly, and I know it changes per piece, but how do you time them in the tank?
Certainly. So it definitely does change per piece. You know, I've done small slices that were, just had little minor blooms of rust going on. And those I would run for about a week, take them out, let them sit open air, make sure they stay stable, make sure they don't change. I've had chunks of Sriracha that were heavily encrusted, the bits that came out of the swamp. And I've run those for 2 months straight.
Jeez.
Just to make sure I'm really getting all the way in there. And, periodically I would take them out and bust off all the caked up rust. Like there's a piece of Sriracha you see there. And you can see how dirty it is. You see my hands there. That's all just rust from the piece.
Wow.
From wire wrapping it. One thing you do want to make sure you hook up your electrical leads in the right order because you want to take the rust off the meteorite, not put more on it. So again, you want to be reducing the meteorite. And then the other thing you want to make sure is, right, so you don't want any copper in the water. You don't want stainless steel in the water. You want the meteorite in the water and you want some plain steel going in there. Those two things are safe to be in the solution. You start putting things like stainless in there or copper, you're either going to get plating action going on or you're going to be releasing some fumes that you really don't want to be breathing. So you are off-gassing hydrogen too while you do this. So you do want to make sure you have good circulation and you're doing it in an area that's well ventilated. You're not going to build up gases there. And I'd say recommend don't put direct fans or anything like that blowing on there because you have a motor then running next to there that is a source of potential sparks. So you don't want hydrogen and sparks together.
Wow. Very, very good information. Thank you so much, man. Appreciate you sharing that with us. And that, what you were showing was just a process on whole stones. You also do that on slices as well. But Ron Metchkis on our crew has put together a few videos of his iron slice restorations all the way down to refinishing and re-etching and coating for the future. So I highly recommend checking those videos out too, because he goes a lot more detail step by step of the finishing process. But Mike, thank you for taking us through the equipment and devices you use. Really appreciate it.
Certainly. I got one more if you got time and you want to see one like quick 35-second thing.
Go for it, man.
So talking about curating pieces, we just talked about the irons. If you have chondrites and they start showing a little bit of rust to them, you're obviously not going to run electrolysis on a chondrite slice. So a lot of people clean up their chondrite slices when they get a little bit of surface rust, and everyone always uses paper. Basically sanding wet dry paper. One of the things I was going to say, this is your run-of-the-mill lap disc. For what you pay for a pack of sandpaper, you can get yourself a lap disc, and you can just take that lap disc and run it on not a lap machine, but a nice flat tile, right? And you can use a little distilled water or 90% alcohol on there, and you can refinish your slices like that. And economy-wise, that disc will last you a lifetime of collecting. So it's a lot more affordable than going through paper every time you want to go ahead and clean up a slice. And inevitably, you'll get a slice that you're unhappy with the finish on it. It might have a cutting tab or something like that. So a couple cheap lap discs, even if you don't have a flat lap machine, a disc on a tile will keep you nice and true and flat, and you're able to clean up any imperfections you have on your slices.
What's the grit on the lap?
So you can get them in any grit, running from like 180. They make even coarser ones. They make down to 60, which is insanely coarse, all the way up into the thousands. So what I would recommend is, if you want to clean up slices that have cut tabs and stuff like that, I would get like either a 320 or a 500, which is medium kind of grit to it. And then if you want to clean up slices with just minor blooms of rust around some of the iron blebs, or you have some fine saw marks on there and you want to clean up, 1,000 is a decent grit to kind of take things to where they're semi-gloss finish, and they're nice and smooth. So those two are probably the workhorses that I would say to go for. And again, they're like $15. So
That is
$30
great.
bucks. $30 is 2 packs of sandpaper.
That's a great way to make the most on a budget and convert some of the pieces you may already have in your collection to a little higher quality pieces. So thank you very much, man.
Yep.
Everyone, thanks for joining us this week. Catch us in 2 weeks when we have more meteorite education. Good night, everyone. Bye-bye.
Good night.
Bye.
Bye-bye.
Hey.